Okay, this is problem number 32. Now, certainly, I want to talk through this substitution that we're going to be using and some background on it. So I'm going to probably hack this guy's name, but it's pronounced, I believe, Weierstrass, and it's known as a Weierstrass substitution. All right. So, the bottom line is it basically, you'd say, how does someone come up with these things? I guess just an understanding of a lot of details that escape a lot of people, myself included, by the way. But he makes this substitution over here, right? And he transforms an integral where the integrand is some function of the sine and cosine, right? So, for example, this one over here, it's some function of the sine and cosine, right? I definitely see the cosine there. And then he says he's going to basically say cosine is equal to this, the sine is equal to this, and the dx would be equal to this over here. And this transforms the integral into possibly a simpler integral. This is also called the half-angle tangent substitution. We'll go through the derivation a little bit later. But let me just go to the next page over here. And, according to Michael Spivak, again, we'll go through this, don't worry about that. According to Michael Spivak, right, this is the world's sneakiest substitution. All right? Now, granted, someone says, who's Spivak? Spivak wrote a book, calculus book, that's pretty much used all over the world for students wanting to major in mathematics, right? So it's a book that's been around a long time. All right, we'll go back and do the problem later. But right now, I do want to point out some things that you learn in pre-calculus you can't remember. This is one thing you may not be able to remember, this identity over here. Now, if you went back to your pre-calculus course, it typically is given when you're introduced to some double angle and half angle formulas. And this is derived, right? Derived from those things, all right? Now, let me just talk a little bit about this guy, Weierstrass, right? German, mathematician. He's cited as the father of modern analysis. I know him best for the intermediate value theorem. But the bottom line is he was a bright guy, all right? However, he did not get a degree in mathematics. He studied mathematics and he trained and he taught. When he taught mathematics. He also taught physics, botany, and gymnastics. All right? Now, I do want to also point out that the way the name is written down, I certainly wrote it down in honoring how he would have written it down, but in the West, we certainly do this over here. And again, I believe it's pronounced Weierstrass. Again, a German pronouncing that, it would sound a lot better than me pronouncing it. All right? We're going to go through this separately, by the way. So I'll go through the technique. We'll do many examples over here, and I'll also go through the derivation. But right now, it's sufficient to know that we have this new method. And this new method depends on a substitution where t is equal to this thing over here, and you've got an integrand where it's going to be involving sines and cosines. All right? We make a substitution, and we'll go through examples, and we'll go through just more than one example. All right? I'll also go through the derivation. Thank you.